What are the bends?
Nitrogen under normal atmospheric pressure is nearly insoluble in blood. Under pressure, the solubility increases. Thus, as a diver goes deeper, the blood holds more and more nitrogen, which dissolves in the blood during gas exchange in the lungs. As the diver ascends, the pressure decreases, and hence the blood is now supersaturated with nitrogen. The supersaturated nitrogen forms bubbles as it comes out of solution in the blood, or cells. These bubbles collect in veins and arteries. They cause pain, and can rupture cell walls and block the flow of blood to cells, causing injury or even death. The best way to avoid the bends is to rise to the water surface slowly, allowing the liquid pressure from the water to gradually decrease and prevent any physical damage. Most scuba divers use nitrox that contains 35% oxygen and 65% nitrogen, rather than normal air that contains 20% oxygen and 80% nitrogen, to reduce, but not eliminate the possibility of getting the bends.
What distinguishes objects that sink from those that float?
An object will sink if the downward forces on it are larger than the upward forces. There are two downward forces: the force of the liquid above the object and its weight, the force of gravity. The upward force is the force of the liquid below it. Let's think of a cubic object of height h and area of the top and bottom a. Its volume, V, is then given by V equals Ha. Density is the mass divided by the volume, or P equals m/V. Let's start by considering the difference in water pressure between the bottom and top of this cube. Pressure is force divided by area, so, using L bottom equals top plus water GH. We can write bottom/A equals phi top/A plus water GH, so bottom equals phi top plus water caret ha. Now we recall that Ha is the volume of the cube and water Ha is therefore the mass of the water. Water, whose place is taken by the cube of matter. The net downward force on the object in the water is then the force on the top plus the object's weight less the force on the bottom. That means Fnet equals phi top plus mobject, bottom, from the results of the paragraph above. Fnet equals mobject, waterg. Therefore, if the object's mass is larger than the mass of the water whose place it takes, it sinks. If the mass is smaller, then it will rise. Weight is the mass times the gravitational field strength, g, so the net force is Fnet equals wobject, waiter. The water whose place the object takes is normally referred to as the water displaced by the object.
Why do your ears hurt when you dive to the bottom of a swimming pool?
Just as the weight of the air above us creates atmospheric pressure, The weight of water creates liquid pressure. Close to the surface of a pool there is very little water that can push down and increase water pressure. The further a person dives below the surface, however, the greater the water pressure. The eardrums are especially sensitive to the increased pressure, for they do not have the reinforcement that the diver's skin has. In fact, your eardrums can usually feel pressure when diving just 1.5 to 3 meters. 5 to 10 feet, below the surface of the water. Feet, deep or in the ocean at a depth of 10 meters, 32 feet. Although the ocean contains a lot more water than a lake, it is the depth that determines the weight of water directly over a diver that defines the amount of pressure the diver experiences. Therefore, a diver who is 20 meters below the surface of a lake will experience more pressure. In fact, twice the pressure than the ocean diver experiences at 10 meters. Salt water is denser than fresh water, but the increase in pressure caused by the increased density is small in comparison to that caused by the difference in depth.
Does a musical tone have a single frequency?
It does not have a single frequency, but many. To understand why, consider a stringed instrument like a guitar, piano, or violin. The string can oscillate in response to it being plucked, hit, or bowed. Standing waves will be formed as they would be if you shook a rope back and forth. By shaking it at different frequencies you can make it oscillate in several different modes. The lowest frequency results in nodes only at the ends. Twice this frequency produces nodes at the ends plus one in the middle. 3 times the lowest frequency give nodes at the ends plus 2 nodes at 1/3 and 2/3 its length. If you pluck, hit, or bow the string of a stringed instrument you cause it to vibrate. In many of those nodes at the same time, depending on the location you plucked it. The lowest frequency of oscillation is called the fundamental frequency. Plucking the string 1/4 from one end results in oscillations at 2, 3, 4, 6, and 7 times the fundamental frequency. The higher frequencies are called harmonics. For example, if the fundamental frequency were middle C, 256 Hz, then the second harmonic would have a frequency of 512 Hz, the third 728 Hz, the fourth 1024 Hz, etc. The sound made by the vibrating string is very weak. On acoustic stringed instruments the strings pass over the bridge that transmits the oscillations to the top plate of the body of the instrument. Low-frequency sounds also excite oscillations in the ear and in the bottom plate of the guitar's body. Sounds from the oscillations of the ear pass through the sound holes in the top plate into the surrounding air. The amplitude of the fundamental frequency is the largest. The relative amplitudes of the higher harmonics depend not only on the string, but the shape and size of the body of the instrument. Electric guitars will be discussed in the chapter on magnetism. The relative intensities of the higher harmonics depend on the instrument. The sound spectrum produced by the instrument is characterized by these relative amplitudes. The spectrum is also called the quality of sound, or the timbre. The sound quality also depends on how the sound starts and stops.
What is a difference tone?
Frequencies produced as a result of two different frequencies mixing with each other.
How are microwaves used for communication?
Microwaves are electromagnetic waves with frequencies above about 3 GHz. They are used in homes equipped with wireless internet devices. Wireless telephones, Bluetooth devices, for satellite radio and television. In addition, industries, governments, and the military use microwaves for communicating from one installation to another. Microwaves can be transmitted one of two ways. The first is the line-of-sight approach, where the microwave transmitter is pointed at a microwave receiver. These must be no more than 30 kilometers apart. The second method of transmission is to send the signal up to a satellite that receives it and retransmits it back down to a receiving dish.
What is gravitational field strength?
Ratio of gravitational force to mass of attracted object, G equals 9.8 N/kg.
How fast does sound travel?
Light travels almost 1 million times faster than sound, specifically, 880,000 times the speed of sound. Light and all electromagnetic waves travel at a speed of 3 × 10 meters per second. While the speed of sound is only about 340 meters per second or 760 miles per hour on a typical spring day.
What is geophysics?
Study of the forces and energy found within Earth, including tectonic plates, earthquakes, volcanic activity, and oceanography.
What is the function of the grating on the door of a microwave oven?
People using microwave ovens want to see the food cooking inside the oven, yet not be bombarded by potentially harmful microwaves. In order to prevent the escape of microwaves through the plastic or glass door, a grating consisting of small holes is used to reflect the microwaves back into the oven. The microwaves, which have a wavelength of about 12 centimeters (4.7 inches), are too big to pass through the holes, but visible light, whose wavelength is smaller than the opening, can easily pass through the grating. Although the grating protects people from the microwaves, some microwaves can still leak out through the door seal, however, if it's not cleaned occasionally.
What is sound intensity?
Sound intensity is the power in the sound wave divided by the area it covers. Power is energy per unit time. So the intensity is the wave energy passing through a surface point divided by the time taken. The energy transferred by the wave is proportional to the square of the amplitude of the wave. In the case of sound, the amplitude is the amount the peak pressure in compression is greater than the average pressure.
Do electric eels really use electric fields to capture their prey?
Electric eels do indeed set off electrical pulses to stun and even kill their prey. These eels have special nerve endings bundled together in their tails that can produce 30 volts in small electric eels to 600 volts in larger eels. Besides using the electrical shocks for hunting, the eels produce a constant electrical field for use in navigation and self-defense. Most people do not have to worry about encountering electric eels, however. This variety of eel is native only to the rivers of South America.
What combination of charges causes attractive and repulsive forces?
As you observed, unlike gravitational forces, which only attract masses to each other, electrostatic forces can either attract or repel charges. Like charges, positive or negative, repel each other. Unlike charges, positive attract each other. A common phrase describing many human social relationships. Opposites attract, holds true for electrostatic forces.
What is magnetic declination?
Magnetic declination is the angular difference between north as shown by a compass and the direction to the geographic North Pole, Earth's axis of rotation. Declination depends primarily on the location on Earth, but, because the magnetic poles move, also on time.
What is a reflecting telescope?
A reflecting telescope uses a mirror to gather light and focus the light toward the eyepiece. It usually consists of two mirrors, one large curved mirror at the end of the Telescope to gather light and a smaller mirror used to direct the light to the eyepiece.
How is temperature measured?
Temperature is measured by a device called a thermometer. There are many different kinds of thermometers, but they all have a property that depends on temperature. The most common type of thermometer contains a thin column of liquid in a glass tube. When the temperature goes up, the liquid expands, and the height of the column increases. Earlier thermometers used mercury, a metal that is a liquid at room temperature. Because mercury is poisonous, all thermometers sold today contain red-colored alcohol. The glass tube has markings on it from which the temperature can be read. Many thermometers today are electronic. Most contain a tiny bead of a semiconducting material whose resistance varies with temperature. The bead is called a thermistor, or thermal resistor. Others contain a tiny semiconducting diode. The voltage across this diode varies with temperature. To measure very high temperatures, a wire made of the metal platinum is used because its resistance also varies with temperature, and platinum is not affected by high temperatures. Another electronic thermometer uses two wires made of different materials that are welded together. Typically the wires are made of copper and a nickel-containing alloy. This kind of thermometer is called a thermocouple and is often used in gas furnaces or water heaters to make sure that the pilot flame is burning when the gas to the main burners is turned on. Voltage and resistance will be discussed later in this book. A less accurate, but convenient thermometer is a strip of plastic whose color changes with temperature. The plastic contains liquid crystals. The geometric arrangement of molecules in the crystals depends on temperature, and so does their color. If two different metals are bonded together in a strip, when the temperature changes, the strip will bend. Because there are two metals, often brass and steel, the device is called a bimetallic strip. This kind of thermometer is often used in household thermostats. This thermometer is similar to one developed by Galileo. The objects inside the tube have varying densities that rise or fall, depending on the temperature.
What determines the amount of reflection or absorption?
A good absorber of sound matches the impedance of sound waves between air and the new medium, while a poor absorber has a very different impedance and reflects the sound back into the environment. Typical absorbers have an open structure with holes of various sizes into which the sound waves can penetrate and transfer their energy to thermal energy of the material.
What is an alloy?
A metal that is a mix of two or more different metals.
What is a nucleon?
Generic name of protons and neutrons.
What is the relationship between current, voltage, and resistance?
Voltage equals current x resistance, or V equals IR. That is, the voltage difference across a resistor is equal to the current through it multiplied by its resistance.
What is a focal point?
Location where light rays from a very distant object are reflected from a mirror or refracted by a lens to come together.
What is a sound intensity?
Power in a sound wave divided by the area it covers.
Who developed gears?
As early as 2600 B. CE in India and other parts of southern Asia, gears were used to open and close doors in temples and to lift water. Around 400 BCE, Aristotle, 384 to 322 BCE, described how gears were used. Archimedes described worm gears around 240 BCE. And in 40 BCE Vitruvius showed how gears could convert motion from a horizontal axle to a vertical one. In the 1300 CE gears were used in clocks in bell towers and on churches.
How can you represent a vector quantity such as displacement?
A convenient way to represent a vector is to draw an arrow. The length of the arrow represents the magnitude of the vector. Its direction represents the direction of the arrow. For example, you might create a drawing where 1 inch on the drawing represents 100 feet. And west points toward the left edge of the paper. Then the displacement of the house from First Avenue would be represented as an arrow 1.6 long pointing toward the left.
How does one become a physicist?
The first requirement to be a physicist is to have an inquisitive mind. Albert Einstein, 1879 to 1955, himself admitted, "I'm like a child. I always ask the simplest questions." It seems as though the simplest questions always appear to be the most difficult to answer. These days, becoming a physicist requires quite a bit of schooling along with that inquisitive mind. In high school, a strong academic background including mathematics, English, and science is necessary in order to enter college with a strong knowledge base. Once you are a physics major in college, you will take courses such as classical mechanics, electricity and magnetism, optics, thermodynamics, modern physics, and calculus in order to obtain a bachelor's degree. To become a research physicist, an advanced degree is required. This means attending graduate school, performing research, writing a thesis, and eventually obtaining a PhD, Doctor of Philosophy.
Why does a small clump of steel sink, while a 50,000-ton steel ship can float?
In order to remain afloat, a ship needs to displace an amount of fluid equal to its own weight. Therefore, if a clump of steel is placed in water, it will sink because it is much denser than water and its volume isn't large enough to displace a weight of water equal to its own weight. A 50,000-ton steel ship can easily stay afloat because it can displace 50,000 tons of water. That is because its hull isn't all steel, but contains a large amount of air. Therefore its density, its mass divided by its volume, is less than that of water.
Why is your blood pressure taken from your upper arm?
Liquid pressure is dependent on the depth of the fluid. Since blood pressure can't be measured around the heart, and the depth of the fluid must be the same as the heart, doctors and nurses need to find a location at the same depth as the heart. A convenient location at that level is your upper arm. When lying down, however, your blood pressure can be taken just about anywhere. Since most of the blood is at the same vertical level as the heart, the cuff is inflated until no pulse can be heard. It is then slowly lowered. As the pressure falls below the systolic pressure, the pulse can be heard. When it's below the diastolic pressure, the pulse gets weaker. The report 120/70 means that the systolic pressure is 120 torr, the diastolic pressure 70 torr.
What was done in Los Alamos?
In September 1942, General Groves and Robert Oppenheimer chose Los Alamos, New Mexico, as the site for the top-secret laboratory at which weapons would be developed. 35 miles northwest of Santa Fe. It was almost totally isolated and the site was occupied only by a school. During World War II, hastily erected housing held Nobel Prize-winning scientists. Younger scientists and engineers recruited into the project, wives and children, and soldiers. After determining the critical mass, the minimal amount of enriched uranium needed to create a bomb, they designed and built the uranium-based weapon called Little Boy. The uranium was divided into two halves and placed in a cannon-like container. An explosive charge drove the two masses together, forming a large enough mass of uranium to sustain a rapid chain reaction and explode. This weapon was never tested. It contained 64 kilograms, 141 pounds, of uranium, about 2.5 times the critical mass. Less than 1 kilograms, 2 pounds, of the uranium fissionate. Only 0.6 grams, 0.001 pounds, was converted into energy. But the result was the equivalent of 15,000 tons of TNT. Little boy was dropped on Hiroshima, Japan. On August 6, 1945. Over 100,000 people were killed in the blast, resulting fires and effects of radiation. The second task of Los Alamos was to design and build a weapon using plutonium. Originally they had expected to use the cannon-type method used with the uranium bomb. But when the plutonium was produced by the Hanford reactors, it was found to contain 240 Pu. And another design had to be developed. They arranged a subcritical plutonium mass in the shape of a sphere and used specially designed explosive charges to simultaneously compress the plutonium, increasing its density above the critical point. Scientists were uncertain that the design would work, so they decided to test the device first.
Does sound's intensity always follow the inverse square law?
Sound doesn't always spread uniformly. You may have experienced this if you shout while you walk through a tunnel. You hear echoes and a person at another part of the tunnel will hear you much more clearly than he or she would in an open area. Whispering chambers are often found in science museums. They are rooms with walls in an elliptical shape. If you stand at one focus of the ellipse and another person stands at the other focus, you can hear each other speak even if you whisper while other people in the chamber are talking loudly. Sound can also be transported through the ocean with less spreading using an acoustic waveguide. Similar to the way light can travel in an optical fiber, see the chapter on light. The ocean water can separate into layers at different temperatures. The speed of sound depends on water temperature, and if there is a layer of cold water where sound speed is lower under a layer of warmer water where the speed is higher, then some of the sound moving through the cold layer will be reflected at the boundary back into the cold layer, keeping it from spreading. The name of this channel is sound frequency and ranging, so far, channel. It is 100 to 200 meters below the surface in the cold waters off Alaska but 750 to 1,000 meters deep in the warmer Hawaiian waters.
What official titles did Newton receive?
Newton was extremely well respected in his time. Although he was known for being nasty and rude to his contemporaries, Newton became Lucasian Professor of Mathematics at Cambridge in the late 1660s, President of the Royal Society of London in 1703, and the first scientist ever knighted. In 1705, he was famous as the master of the mint, where he introduced coins that had defined edges so that people couldn't cut off small pieces of the silver from which the coins were made. He is buried in Westminster Abbey in London.
What is Kepler's first law?
Planetary orbit is an ellipse with the Sun at one focus.
How can the acceleration be independent of mass? Doesn't a bowling ball fall faster than a soccer ball? Which weighs more, the bowling ball or soccer ball?
You can use your hands to hold first one ball and then the other. You'll notice that you have to exert a much larger upward force to hold the bowling ball at rest. From Newton's first law, if an object is at rest, then the net force on it is zero. That is, the downward force of gravity has the same strength as the upward force of your hands. So, you can conclude that the force of gravity, the weight of the bowling ball, is greater than that of the soccer ball.
Does momentum apply to objects that rotate?
Quantities that describe rotation are similar to, but different than, those that describe straight line motion. Position is replaced by angle, velocity by angular rotation. Acceleration by angular acceleration. Force is replaced by torque.
What are complementary colors?
Complementary colors are pairs of one secondary and one primary color that, when mixed, form what is close to white light. For example, yellow and blue light are complementary because when combined, they form white light, as will magenta and green, and cyan and red.
What is a DC circuit?
In a DC, or direct current, circuit charges travel only in one direction. The voltage source, a battery or direct current power supply, has one positive and one negative terminal, so there is current in only one direction.
When a car makes a turn, what supplies the centripetal force on it?
The road supplies this force. The road is in contact with the tires. and friction between the tire and road is necessary for the force of the road to be exerted on the car. If the road is covered with ice, the friction often isn't large enough and the car goes straight, rather than along the curve. A racetrack is often banked so the tilt of the track can supply at least part of this inward force, reducing the need for friction. If you're sitting in the car, there must be a sidewise force on you so that you stay with the car as it makes the turn. Usually the friction between you and the seat is sufficient, but sometimes you have to hold onto the door handle to exert more force.
Inclined plane?
Simple machine used to help lift an object.
What can you discover about static electricity? How about exploring the basic ideas of electrostatics?
All you'll need is a roll of cellophane tape. Any brand will do, the cheaper the better. Pull off a strip about 5 inches long, then fold over about 1/4 inch at one end to serve as a handle. Press the tape on your desk or a table. Mark the strip with the letter B. Make a second identical tape, and press it down next to the first. Holding the two tapes by their handles, quickly pull them off your desk. They'll probably be attracted to your hands, so shake them until they hang free. Then bring them closer together. What do you see? You should see them bending, evidence that there is a force between them. If they don't bend, stick them on the desk again and again, pull them off. Do they provide evidence that there is an attractive or repulsive force between them? Well, say that pulling them off the table caused them to be charged. Although we have no evidence with what they are charged, they were obviously charged in the same way. So we can conclude that objects with like charges repel each other. By the way, we'll work toward an explanation why they're attracted to your hands. Press the two strips back on your desk. Now make 2 more strips the same length and press them on top of the first 2 strips. Mark these strips T to identify them as the top tapes, as opposed to the B or bottom tapes. Slowly pull the T and B pair of tapes off the desk together. If they are attracted to your hand, then use the other hand to gently pat both sides of them over their entire length. That should remove any residual charge from the pair of tapes. If not, pat them down again. You have a pair of objects with no charge. Holding the 2 handles of the pair, rapidly pull them apart. Again, if they are attracted to your hands, shake them until they hang freely. Bring them closer together. Is there evidence of a force between them? Is it attractive or repulsive? You started with a pair of objects with no charge. Pulling them apart caused them to be charged, but not in the same way. Because they didn't repel each other, but attracted. Thus you can conclude that they must be charged differently, and objects with different charges attract. To keep your charged tapes you can hang them from the edge of your desk or a desk light. Make a second T and B pair and see if the two top tapes are charged alike or differently. If the tapes stop interacting you can repeat the charging procedure as often as you like. Hang a T and a B tape so you can bring objects near them to see if there are forces between them. Make a list of the objects you tried and whether they attracted or repelled the T tape and the B tape. Try your finger. Then try rubbing a plastic pen on a piece of wool. Try plastic rubbed by silk or polyester. Try glass and metal. Do some objects attract? Both tapes? Repel both tapes? Attract one and repel the other? If they do the latter, you can characterize them as being charged like the T tape or like the B tape. Well, come back to understand why some objects can attract both kinds of charge, but no objects can repel both.
What determines the velocity of a wave?
The velocity of a wave depends upon the material or medium in which it is traveling. Typically, the stronger the coupling between the atoms or molecules that make up the medium, and the less massive they are, the faster the wave will travel. All waves of the same type, transverse or longitudinal, travel at the same speed. For example, a sound wave in air at 0 degrees Celsius will travel at 331 meters per second. Regardless of the sound's frequency or amplitude. Electromagnetic waves can travel either through empty space or through material. Their velocity depends on the electric and magnetic properties of space or the material, but not on frequency or amplitude. The velocity of water waves depend both on the properties of the water and on the frequency of the wave.
How do day/night rear-view mirrors function in vehicles?
When drivers traveling at night encounter a bright light from the vehicle behind them shining in their eyes, many will flip a tab on the underside of the rear view mirror to deflect the light up toward the ceiling of the car. The silvered surface of the mirror reflects approximately 85 to 90% of the incident light on the mirror, which is now directed toward the ceiling. The remaining 10 to 15% of the light is reflected by the front of the glass on the mirror. The mirror is wedge-shaped, thicker at the top than at the bottom. Thus the front surface is angled downward to allow the much smaller amount of light to be reflected into the driver's eyes.
Why shouldn't metal objects be placed inside microwave ovens?
Manufacturers caution consumers about placing metal containers and aluminium foil inside microwave ovens for two main reasons. The first reason is that metal and aluminium may impede cooking. Microwaves warm food by transmitting energy to water and fat molecules within the food. If food is placed under aluminium foil or in a metal container, the microwaves will be reflected from the metal and won't be able to reach the water molecules and cook the food. The second reason for not placing metal objects inside a microwave oven is for the safety of the microwave oven itself. Metal acts as a mirror to microwaves. If too much metal is placed in the oven, the microwaves will bounce around the oven in waves that can damage the magnetron that produces the microwaves. If the metal is the correct size, it can act as a microwave receiver, and the induced voltages can produce sparks that can ignite the food.
If you now let go, will the box continue to roll or will it go backwards?
It depends on the relative locations of the center of gravity and the force of the surface as seen in the illustration above. If the center of gravity is above the bottom of the box, then the box will return to its upright position. If the center is directly above the corner of the box, then the box won't rotate at all. If the center is outside the bottom of the box, then it will tip over.
How do liquids evaporate?
A substance does not have to boil to change from liquid to gas state. The boiling point is where the pressure of the water vapor equals the atmospheric pressure. At all temperatures there is a great variation in the kinetic energy of the molecules that make up the substance. When the molecules with high energy reach the surface, they have the possibility of escaping into the air. The process of changing from liquid to gas at a temperature below the boiling point is called evaporation. When the molecules with higher energy leave the liquid, the remaining molecules have a lower average energy, and thus a lower temperature. It is cooled by evaporation.
When a solar eclipse occurs, is the entire Earth in the Moon's shadow?
The shadow of the Moon only covers an area of about 300 kilometers in diameter. This shadow, the umbra, moves along a path of Earth's surface at about 1000 miles per hour. In the penumbra a partial eclipse is seen, but even this path is quite narrow.
Why did Einstein win a Nobel Prize for the photoelectric effect, but not for relativity?
Einstein was a controversial person. He was Jewish and a strong supporter of pacifist causes. In addition, his approach to theoretical physics was very different from physicists of that time. He was repeatedly nominated for the Nobel Prize, but members of the prize committee, despite his public fame, refused to grant him the prize. Most likely for political reasons. The 1921 prize was not awarded. In 1922 the committee found a way to compromise. Einstein was awarded the 1921 prize for the photoelectric effect because of the way it could be tested experimentally.
What is the instantaneous speed, v?
Limiting value of distance divided by time interval when the time interval is reduced to 0.
What are the limits of human vision?
Lower and upper boundaries of light. 4x 1014 Hz or 700 nanometers and 7.9x 1014 Hz or 400 nanometers.
What is a flavor?
Generation of quark, up/down, strange/charm, top/bottom, or lepton. Electron/electron neutrino, muon/muon neutrino, tau/tau neutrino.
How did fiber optics originate?
The idea that light could travel through glass strands originated as far back as the 1840s. When physicists Daniel Collodon and Jacques Bobinet, 1794 to 1872, demonstrated that light could travel through bending water jets in fountains. The first person to display an image through a bundle of optical fibers was a medical student in Germany by the name of Heinrich Lamm, who, in 1930, used a bundle of fibers to project the image of a light bulb. In his research, Lamm ultimately used optical fibers to observe and probe areas of the human body without making large incisions. From that point on, serious research in optical fibers ensued, expanding later with the development of the laser. Fiber optics are glass fibers that transmit laser light that can contain digital information more quickly and efficiently than metal cables.
Where are AM and FM broadcasts found in the electromagnetic spectrum?
In the United States, commercial AM stations broadcast between 550 kHz and 1600 kHz. Commercial FM stations broadcast between 88 MHz and 108 MHz. In the AM band, the frequencies of stations are spaced by only 10 kHz. As a result, the broadcasts are limited to sound frequencies up to only 4 kHz. While the ear can detect frequencies as high as 15 kHz.
What is three-dimensional, 3D, vision?
Seeing in 3 dimensions, which is how a person with normal eyes sees. Means that in addition to perceiving the dimensions of height and width, such as seen on a piece of paper, a poster, or a TV or movie screen, one can see the third dimension of depth. We see real objects in 3D because we have 2 eyes that see slightly different perspectives of the same view. The combination of these views, when interpreted by our brain, gives us the ability to perceive depth, the third dimension. If you close one eye, your ability to perceive depth is eliminated. With only one eye, the world won't look very different to you. But you'll experience difficulty in judging distances.
Where do X-rays come from?
X-rays are electromagnetic waves of very short wavelength. Alternatively, they are very high-energy photons. They are emitted by atoms with many electrons, such as those high in the periodic table. The more electrons, the greater the charge of the nucleus. And the higher the energy of the electrons that are close to the nucleus, with n equals 1 or 2. Therefore, when the atom is disturbed, as it is in an X-ray tube when the anode is bombarded by high-energy electrons, one of the n equals 1 electrons can be kicked out. When an n equals 2 electron loses energy and takes the place of the kicked out electron, an X-ray is emitted.
What is subtractive color mixing?
Combining dyes, pigments, or other objects that absorb and reflect light.
What is farsightedness?
Also called hyperopia. Allows only objects far from the eye to be focused on retina. Images from close objects are behind the retina so they are blurry.
What is thermal physics?
Thermal physics is the study of objects warm and cold, and how they interact with each other. It is difficult because most of the vocabulary dates from the time before scientists understood what makes an object hot. Terms like heat, heat capacity, and latent heat suggest that warm objects contain some material that depends on their temperature. As was discussed in the chapter on energy. It wasn't until the early 1800s that our present understanding was developed. Yet, almost 200 years later, our common usage is based on earlier ideas.
What is the most aerodynamic shape?
Some think the narrower and more needle-like an object is, the lower its drag force will be. Although a needle head cuts easily through the wind, the problem emerges at the tail end, where the wind becomes turbulent and forms small eddy currents that hinder the streamline flow of air. The optimum shape depends on the velocity of the object. For speeds lower than the speed of sound, the most aerodynamically efficient shape is the teardrop. The teardrop has a rounded nose that tapers as it moves backward, forming a narrow, yet rounded tail, which gradually brings the air around the object back together instead of creating eddy currents. At high velocities, such as a jet airplane or a bullet may travel, other shapes are better. For turbulent flow, the least drag comes from having a blunt end, which intentionally causes turbulence. The rest of the air then flows smoothly over the region of turbulence behind the object.
Why are lightning rods effective in keeping tall trees and homes safe from lightning?
Lightning rods are pointed metal rods that are installed above a tree or rooftop to protect the object. The rod, connected to the ground by a metal wire, both encourages and discourages a lightning strike. The rod discourages the lightning strike by leaking positive charges out of its pointed top to satisfy the need for positive charge in the clouds. If the rod cannot leak out enough charge to satisfy demand, the stepped leader from the cloud is instead attracted to the rod, and a flash of lightning occurs. Therefore, the rod attempts to discourage lightning, but if it cannot satisfy the negative charge, it attracts the lightning to the rod instead of the tree or house. If the lightning rod doesn't have a good connection to the ground through the wire, it can increase the danger to the building. Often these heavy grounding wires come loose from the lightning rods, and if the rod is then hit by lightning, the charges will flow along the surface of the building to the ground and could cause a fire. The rods can become disconnected from lack of routine maintenance. It is wise to check these connections on a regular basis.
What are the types of simple machines?
There are four major groups of simple machines: levers, including wheels and axles; pulleys, including gears, and the inclined plane, including wedges and screws.
How can evaporation be a cooling process?
Because evaporation leaves a cooler liquid, the material on which the liquid rests is cooled. Evaporation is an effective way to cool our bodies. Perspiration leaves a coating of water on our skin that evaporates, cooling the skin. Alcohol evaporates more quickly than water and has an even greater cooling effect. For that reasons, parents are advised to rub alcohol on the Skin of babies who are running dangerously high temperatures. It can reduce the fever and keep the baby out of danger.
What are the frequency limits of the human ear?
The ear allows humans to hear frequency ranges between 20 Hz and 20,000 Hz. But it is most sensitive to frequencies between 200 Hz and 2000 Hz.
What was the first clock?
For thousands of years the second. And all other units used to measure time, were based on the rotation of Earth. The first method of measuring time shorter than a day dates back to 3500 BCE, when a device known as the gnomon was used. The gnomon was a stick placed vertically into the ground which, when struck by the sun's light, produced a distinct shadow. By measuring the relative positions of the shadow throughout the day, the length of a day was able to be measured. The gnomon was later replaced by the first hemispherical sundial in the 3rd century BCE by the astronomer Berosus, born about 340 BCE.
What is the difference between cones and rods?
Cones are cone-shaped nerve cells on the retina that can distinguish fine details in images. They are located predominantly around the center of the retina called the fovea. The cones are also responsible for color vision. Some cones respond to blue light, being most sensitive to 440 nanometer wavelengths. A second kind has peak sensitivity in the green, 530 nanometer light. The third is sensitive to a wide band of wavelengths from cyan through red. Its sensitivity peaks in the yellow, 560 nanometers. As the distance grows from the fovea, rod-shaped nerve cells replace the cones. The rods are responsible for a general image over a large area, but not fine details. This explains why we look at objects straight on when examining something carefully. The image will be focused around the fovea, where the majority of cones pick up the fine details of the image. The rods, being much more sensitive in low light levels, are used a lot for night vision.
How can infrasonic sounds provide early warning of tornadoes?
Using sound sensors that detect infrasound, scientists discovered quite by accident that the spinning core or vortex of a tornado produces sounds that are a few hertz below the human bandwidth of hearing. The tornado, much like an organ pipe, produces low frequencies when the vortices are large, and higher frequencies when the vortices are small. Since the infrasound waves from tornadoes can be detected for up to 100 miles away, They could help increase the warning time for tornado strikes.
What happens to a series circuit if more bulbs are added?
If more light bulbs or other resistors are placed in a series circuit, there is more resistance in the circuit. And so the current, and the brightness of the lamps would be reduced.
What happens to the momentum of the ball and you and the chair altogether?
As long as external forces are zero or small, then in any interaction the momentum of the system, in this case the ball, you, and the chair will be constant. This result is called the conservation of momentum. The sum of the decrease in momentum of the ball and the increase in momentum of you and the chair will be zero.
What is inertia?
Inertia is the property of matter by which it resists acceleration. That is, an object that has inertia will remain at rest or will move in a uniform motion in a straight line unless acted on by an external force. In this simple pendulum game called Newton's cradle, lifting one hanging ball and allowing it to drop and hit the second ball exerts a force on the next ball. The force on the ball at the other end causes it to swing out and back, according to Newton's laws.
What other major force can be experienced by structures?
A torsion force, usually from winds, is responsible for twisting structures. Buildings, bridges, and towers use cross supports to prevent such forces from damaging the structures. For example, the John Hancock Building in Chicago has visible cross supports.
What is an atomic number?
Number of protons in the nucleus and thus the nuclear charge.
What is colorimetry?
Measurement of the intensity of particular wavelengths of light.
Why are dams thicker at the bottom than at the top?
Dams hold back bodies of water, and water pressure increases with the depth of the body of water. So the pressure from the water pushing horizontally on the dam is greater at the bottom than at the top. If holes were bored near the bottom, middle, and top of a dam, the longest horizontal stream of water would fire out through the bottom hole because the water pressure is greatest there.
Why did Gabriel Fahrenheit define the freezing point of water to be 32 degrees Fahrenheit instead of 0?
Fahrenheit did not define 32 degrees as the freezing point of water. Instead, he defined 0 degrees as the freezing point of a water and salt mixture. Since salt lowers the freezing point of water, the freezing point for this mixture was lower than it would have been for plain water. Upon defining the degree intervals between the freezing and boiling points of the water and salt mixture, and he found that water itself freezes at 32 degrees Fahrenheit.
What is the Nobel Prize?
The Nobel Prize is one of the most prestigious awards in the world. It was named after Alfred B. Nobel, 1833 to 1896, the inventor of dynamite. He left $9 million in trust, of which the interest was to be awarded to the person who made the most significant contribution to their particular field that year. The awards, given in the fields of physics, chemistry, physiology, and medicine, literature, peace, and economics, are worth over $1,400,000, and a great deal of recognition.
What is an antinode?
Locations in a standing wave where there is the largest amplitude caused by constructive interference.
Is Earth's atmosphere transparent to infrared and ultraviolet radiation as well as to light?
Oxygen and nitrogen, the two principal components of our atmosphere, are transparent to light and to most infrared, IR, and ultraviolet, UV, wavelengths. Infrared from the sun helps warm Earth and long wavelength. Ultraviolet is necessary for our bodies to produce vitamin D. Too much UV, however, harms the skin, and may damage our DNA. A high-altitude layer of ozone in our atmosphere protects Earth from all but a small fraction of the UV radiated by the sun. Ozone molecules have 3 oxygen atoms as opposed to the 2 in oxygen gas. In recent years, large and growing holes in this protective layer have developed due to the emission of chlorofluorocarbon, CFC, molecules from things such as escaped gases from refrigerants and aerosol propellants. Because these gases are no longer being manufactured and existing stocks are gradually being replaced, the growth of the holes should eventually stop. Carbon dioxide, methane, and water vapor are transparent to light and short-wavelength infrared radiation, but are opaque to the long-wavelength infrared emitted by warm objects. They are called greenhouse gases. These gases pass the IR rays that warm Earth but reflect the IR rays emitted by the warm Earth back to the ground. Thus they act as an insulating blanket for Earth. Over the past decades, the amount of carbon dioxide in the atmosphere has increased dramatically. Much of the increase is due to human activity. This increase is likely to lead to a warmer Earth that could shift weather patterns, disrupting food production, causing shifts in locations of forests and animals, and, by melting polar ice, increasing sea levels. The degree of warming and its impact on Earth and humans is under intensive investigation.